All right, in section 13.2, we look at integration by substitution. Go ahead and take a look at example 1, and we want to do the integration here. What I want you to think about is, how did this integram, how did that come about? What had to happen in order to get that to be the derivative of some function? Do you notice anything peculiar? What? The chain rule was used on what? Well, Blake, what did you say?
The exponent, or the derivative of the inside parentheses in the first parentheses is the second.
Yes. The derivative of this is sitting right there. And that told you that it was the chain rule. In particular, what else do you notice? There's one other thing. What overall derivative rule was used? The chain rule is incidental. You use the chain rule. What's the overall derivative rule that was used here? That's the 5 and a 4. What?
That's what G is.
I was looking for something a little more specific. Where's the 5? Where's the 4? What's that called? It's the power rule. This had to start off as this piece, x cubed plus x squared to the 5th power. Do you see this? Because this is the 5 in the front, the inside left alone, decrease the power by 1, take the derivative of the inside, 3x squared plus 2x dx. And of course, if we're doing antiderivatives, there's always the possibility that there was something added on at the end. So we give that a plus c. Yeah. So, what I want you to realize is that d dx of x cubed plus x squared to the 5th, I'll ignore the c for now, is 5. The inside is the same. Lower the power by 1 times the derivative of the inside. And that's the integrand. The overall derivative was the power rule, but then we used the chain rule to get to the extra part. Luckily for you, we have a way of reversing the chain rule, and that is called integration by substitution. So that's what we're going to learn today. Here is the process of substitution. When you're reversing the chain rule, you pick the inside function to be u, and so you set up what u is. Step 2, find the differential of u. So we're going to have du's and dx's running all over the place. So that's find du. You're going to have a dx on the other side. Then you solve for x or dx, replace in the integral, which is the substitution. That's why it's called substitution. And then evaluate the new integral. Okay. So here we go. Step 1. You want to pick a u that is the inside function from the chain rule, right? It's the one that if you were taking the derivative and you had to run the chain rule on it, you would multiply by that function's derivative. So what is the inside function here? Yeah, it's x cubed plus x squared. And I'm not going to number these. These are, no, we don't number them. All right, now find du. Du is basically the derivative of the u, but then you also multiply by the differential for x, so the dx. So the derivative of u is 3x squared plus 2x. All that times dx. Next, solve for dx. So this will be du over 3x squared plus 2x. Substitute. So we're going to have 5. The x cubed plus x squared is now u raised to the 4th times 3x squared plus 2x times, now replace the dx with what we saw for dx over here. So that's now du over 3x squared plus 2x. Now what cancels? Those cancel. And that leaves me with the integral of 5u to the 4th du. And that's one we can do. That's the point. You substitute out the ones that were too hard to look at and do, and you have now new ones that you can do. So this is going to be 5, raise the power in the u by 1, divide by the new power, plus c. And what does this give me? The 5's cancel. Let me cancel those off. And that gives me u to the 5th plus c. And then back substitute. What was the u? The u was x cubed plus x squared to the 5th plus c. And if you look at the beginning of the page, that's exactly what you told me it would be. Yay. So, recapping. You have to notice that there was a chain rule used in order to get the integrand that you have. Then you let u be the function whose derivative is also there, or at least in some form. We'll get to that in a little bit. But they don't always have to be exact. Then you solve for dx, make the substitution, cancel off all of the old variables so that all you have are new variables, like u's. Then the integration should be easy to do, and you just whip it out. And then that's the answer. And you do the back substitution, and that's the answer. All right. Let's look at example 3. What is the integral of 2x e to the x squared power dx? So the trick for doing this is to look for a function that's in the integrand whose derivative is also in the integrand. What function is in the integrand that its derivative is also there? X squared. So that's what you let u be. So u is x squared. What's du? 2x, and then it's a differential, so we tack on dx. Solve for dx. Dx is du over 2x. Substitute. The u is now x squared, so this is the integral of 2x e to the u times dx is du over 2x. I think I'll cancel in mauve this time. So here's a better one. What cancels? 2x cancels, leaving me with the integral of e to the u du what is the integral of e to the u? One step at a time. E to the u plus c. So you haven't done the integration yet. So you got to do the integration with the u. Then you back substitute. Yeah, take your time. Take your time. Then it's e to the x squared plus c. Questions? All right, let's look at example 4. Example 4 is the integral of 1 over 2x minus 3. This one is a little bit different because you don't see any derivatives of any of the other things there. But we certainly can't integrate this one. It's not just 1 over x. It's 1 over 2x minus 3. The trick here is to let u be the denominator. So u is equal to 2x minus 3. What is du?
How do you know what's in the u?
Well, we don't have any choices here. There's only one thing that would work here, because there's only one thing that's not just x or just a 1 or a number or anything like that. Yeah, and the question really is this: can you integrate this by itself right away? And the answer is no. Yeah, you could if it was just 1 over x. Anything other than 1 over x, you gotta have to substitute out to get it to be 1 over the variable itself. So du is 2 dx. So dx is du over 2. Substitute. So the integral of 1 over 2x minus 3 becomes the integral of 1 over u. The dx becomes du over 2. Now, you see the 2 under the du? That's a constant multiple, just like in derivatives and limits. We can float that out to the front. So it's 1/2 times the integral of 1 over u du. And now, what is the integral of 1 over u? Natural log of the absolute value of u plus c. And so back substitute. So that's 1/2 natural log of, and then replace the u. What was u? 2x minus 3 plus c. Questions? Questions? Tori, questions? Where are you lost at? Blake, question?
How do you get the u for example 3?
For 3?
Yeah.
For 3, you got to be looking for, you got, see this has to work. You got to set it up so that whatever this is cancels. Okay? Because you got to get rid of all the x's. So what I look for, and how are you going to get this 2x? Because u has to be a function whose derivative is 2x. So you're looking for that pair relationship, a function and its derivative both inside of the function. So here is 2x and e to the x squared. I know that the derivative of x squared is 2x. So if I let u be x squared, I'm going to cancel off the 2x. Now, it's not as clear cut on this one, right? But what's the derivative of 2x minus 3? It's a 2. That's a number. Numbers multiply and can float out to the front, and they don't harm anything. So we're good to go. Yeah. So, but if it has variables in it, then you still got to make sure that they cancel up to multiples of those numbers, of those variables, right? So, for example, take a look at example 5. You have the integral of x times the square root of x squared plus 5. Do you see a function and that function's derivative? The answer is no. But now, what about this? Do you see a function and that function's derivative multiplied by some other constant? In other words, it's basically the derivative. It's just not quite the derivative. What's the first function and then what's that derivative? Well, okay. If you choose u to be x squared, then you're going to have the problem of this is going to be the square root of u plus 5, which you don't know how to do you don't know how to integrate u plus 5.
Squared plus 5.
So you take the whole thing. You take u as x squared plus 5, and so then you're going to integrate x and the square root of u. See, you got to get it back down to the single variable. That's the whole point of substitution. Now let's look at the derivative parts. What's du? 2x dx. So this is what I was telling you. Do you have 2x over here? No. But you have x, and that's good enough. Because it's that derivative up to a multiple of itself. So solve for dx. And, oops, why is there an equal sign in the middle? That's a no good. That's a no good. Don't put equal signs in the middle. So this is equal to the integral of x times the square root of u times du over 2x. So again, the x's cancel. It leaves a 2, but that's okay. The 2, having a 2 there is okay. Question? Imani?
Yeah, how do you know it's u is x squared plus 5 and not x?
If u were x, then what are you going to do with the x squared plus 5? See, whenever you make the substitution, you got to substitute out all instances of the variable. If u was just x, then the derivative is there. I mean, it's just du. That's dx. That's no problem. But then you still have this x squared plus 5 deal. You can't have that. You got to get rid of all of the instances of the old variable. So what would this be? 1/2 comes to the front. Integral of u to the 1/2 du raise the power by 1. So u to the 1/2 becomes u to the what? 3/2 divided by 3/2 plus c. Now I'm going to rewrite the 1/2 so that it lines up more properly there. Now the 2's cancel. That 2 was already there, so that was convenient. And so now we have 1/3 on the bottom, or 1/3, 3's on the bottom. We're going to rewrite u as the square root. We're going to replace the u. The u was x squared plus 5, and the 3 on the numerator is a cube, so it's cubed.
Why didn't you take it to the u?
You could have done an extra step here. This would be 1/3 the square root of u cubed plus c. Because remember what 3/2 means as an exponent. The bottom is a square root. The 3 on the top is a cube power. So it's the square root of u cubed. And then back substitute the u. U was x squared plus 5. Now, there's going to be a little bit of trial and error in this. You're going to pick a u, and it's not going to work. That's okay. You pick another u. All right? So you may have to try a couple of these, but the general method is sound. You look for a function and basically that function's derivative up to a constant. Let's look at example number 6. Now this one is tricky. Example 6 says, find the integral of x over x minus 3 dx. So we're going to let u be x minus 3. What is du? 1 dx. Solve for dx, so dx is du. So this would be x over u du. Now what's the problem? You still have an x. What does that need to be? It needs to be something with u, right? Is there a relationship between x and u? What? So what's x? What is it? U plus 3. All right. So you get this extra relationship if you need it. If u is equal to x minus 3, then x is equal to u plus 3. Are you raising your hand or are you exalting like I am? Okay.
Why couldn't you just keep it in the problem?
Oh, you can't keep it in the problem. No, because what's the variable of integration? U. So you can't have any x's. Yeah. So that's the importance of the variable of integration. When you go to substitute, everybody else has got to go. You can't have any other variables around. So what does this become? This is now u plus 3 over u du. And now we solve by splitting it up. So we're going to split up the u into both pieces. So it's u over u plus 3 over u du. U over u is 1 plus 3 over u du. All right. Now, think carefully about the next question. What is the integral of 1? It's not x. U. Because what is the variable of integration? U. So that tells me what the variable was to start with. So what did you take the derivative of to get a 1? U. U. Plus, what's the integral of 3 over u? That's your old friend, 3 natural log absolute value of u plus c. And then back substitute. So it's x minus 3 plus 3 times the natural log of the absolute value of x minus 3 plus c. Look at that. That's pretty good. I'll leave it. Questions? Questions? Who has questions? Weston, questions? Once you get the hang of this, you're going to love it. You'll love substitution. It's really fun.
How did you get rid of that du thing? It was 1 plus 3 times du.
Which one? This one?
To the right.
This one?
No.
Uh-huh.
Then you went down to
That's part of the integration. So the integral sign and the du go together, the bookends for the integrand, and then once you do the process of integration, then you lose both of those and you get a plus c. All right. Example 7. A company predicts that total sales in millions of dollars will increase based on the function s prime of t is equal to 12 minus 6e to the negative 0.1 t for t between 0 and 20 after t months of introducing their new product. What will be the total sales after t months? Assume no initial sales. And then B, what is the total sales after 6 months? All right. So we're looking for s of t. And so that's going to be the integral of s prime of t dt. That's 12 minus 6e to the negative 0.1 t dt. Now, if this had been e to the t, we could just integrate it. But it's not, so we can't. We have to use substitution. So we're going to let u be that exponent. Negative 0.1 t. Then du is negative 0.1 dt. Solve for dt, and you get, well, we'll do this twice here. You get du over negative 0.1, but that's just negative 10 du, because you're dividing by a tenth. That's 10 times. All right. So let's replace it here. So we have 12 minus 6 e to the u times negative 10 du. Bless you. And this is in parentheses as well. So in parentheses, 12 minus 6e to the u times negative 10 times du. All right. Now we can either move the 10 to the front or we can distribute it. What is your preference? Distribution. All right. So this is going to be negative 120 plus 60 e to the u du. And now we integrate. What is the integral of negative 120? Negative 120u. What is the integral of 60 e to the u? That's just 60 e to the u. Because the integral of e to the u is just e to the u. Plus c. Now what? Yeah. So we get negative 120 times negative 0.1 t plus 60 e to the negative 0.1 t plus c. Now, what is 1/10 of 120? That is 12. The negatives cancel. So that gives me 12t plus 60 e to the negative 0.1 t plus c. That is our beginning formulation of S of t. We still need to nail down what the c is. We were told that there are no initial cells. So that means S of 0 is equal to 0. Okay. So, find S of 0. That's equal to 0. So that's 0. 0 times negative 0.1, 0. E to the 0 is 1, so that's 60 times 1 plus c equals 0. So c is equal to negative 60. So S of t is 12t plus 60 e to the negative 0.1 t minus 60. And that was A. And then part B is what are the total cells after 6 months? So you plug in S of 6. So it's 12 times 6 plus 60 e to the negative 0.1 times 6 minus 60. If you work that out on a calculator, I think you get $44.9 million. Just like that. Questions? Okay. All right, go ahead and work on the group work. Let's see how many can we get through here. All right. Let's try to get through the first 4.